Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guided notes called Solving Inequalities and Graphing Their Solutions. This is going to be part one of two videos due to the length of this packet of guided notes. Alright, so let's take a look at this. It asked us to solve each inequality using inverse operations and then graph its solution on a number line. Good news, this is not really that different from what we did when we solved equations. You would ask yourself what's happening to the variable. Here you can see it's being added by 62. The inverse is to subtract by 62. We're going to do it on both sides. The only difference is, instead of having an equal sign in between, we're going to have some type of inequality symbol in between. So here it's a greater than symbol. I know this is a greater than symbol. Remember the trick I taught you guys? If it doesn't match an L, a rotated L, then it is not less than. So this is the greater than symbol. And so 54 take away 62 is negative 8, and we get y is greater than negative 8. Now, after we solve, we're going to graph its solution on a number line. So we create a number line. Negatives go in reverse order from positives. You see number 2. Spoiler alert, we have positives. Positives go in your traditional order. Negatives are like a mirror image of that. Since y is greater than negative 8, we have to go to the right of negative 8, because as you go to the right, the numbers get greater. It doesn't matter if you have positives or negatives. Since this inequality symbol did not have an equal to bar, we're going to leave this an open circle. If it did have the equal to bar, like problem number 2 is going to have, then we would fill in that circle as a closed dot. Okay, let's take a look at problem number 2. We ask ourselves what's happening to the variable. We can see the variable's over here, and it is being subtracted by 91. Inverse, add by 91. We do it on both sides. Negative 79 plus 91 gives you 12. Now, since we like to read in English and many other languages left to right, it makes a lot more sense if the answer begins with the variable. Now, what I mean by that is the variable written to the left of the inequality symbol. You can see here the variable is not written to the left. So if you ever get an answer with the variable on the right, you're going to need to flip that entire thing around and get the variable at the beginning over on the left. So then you can actually read what this answer actually means. 12 greater than or equal to m means m is less than or equal to 12. I know this symbol is a less than or equal to symbol because this looks like an L being rotated, and less than starts with L. So m is less than or equal to 12. So we're going to go to the left of 12. That's where the numbers get less than or equal to 12. Since this had the equal to bar, we fill in the dot. If it didn't have the equal to bar, like number 1, we leave it open. Okay, let's practice this. We're now on the next page. I know there's more to go on the first page. We'll come back to the first page. But let's flip to the next page. Get your pencils ready. Let's do the first 3 problems together. What's happening to the variable on problem number 1? We can see the variable is being added by 87. So inverse is to subtract by 87. Write this down. We're going to subtract on the left, and we're going to subtract on the right. 87 minus 87 is 0. We don't have to show the 0. Bring down the n. Less than or equal to, I know you're used to putting an equal sign here, but it's going to be an inequality symbol. 22 take away 87. Anytime you have a smaller positive minus a bigger positive, that is going to put you in the negatives. If you want to make subtraction become adding the opposite, that's fine. That also will give you negative 65. And now it's time for us to graph. First things first. Does our inequality symbol have an equal to bar? Yes, it does. So, you know what? First things first. That's actually not the first thing. The first thing is to put the negative 65 on the middle hash mark. And then where would I put negative 64? It's actually to the right because negatives are reverse order from positives. If this was positives, then 64 would be on the left and 66 would be on the right. But since they're negatives, it's reverse order. Okay, now that we have that written down, notice there's an equal to bar. Since there's an equal to bar, the way we show it can equal negative 65 is by filling in the dot. If it didn't have the equal to bar, we would leave it open. If n is less than or equal to, that's right, this symbol is less than. It looks like an L that's been rotated, an L for less than. Since it is less than or equal to negative 65, we have to go to the left of negative 65. As you go left, the numbers get less. Doesn't matter that they're positives or negatives, doesn't matter. Left is always less, greater would always be right. Okay, let's do number 2 together. What's happening to the variable? It's being subtracted by 59, so the inverse is to add by 59 on both sides. Write this down along with me. Subtracting is the same as adding the opposite, so this is really a negative 59 plus positive 59, which gives you 0. You don't have to show the 0 step anymore, just bring down the k. K is greater than, well, a negative plus a positive you would subtract in your head. If you really need to use a calculator, you may, but you should remember these basics. Negative plus a positive, subtract in your head. That's how we get 47. Since 59 has a bigger absolute value than negative 12, that's why the answer is positive. Okay. Since we got 47, that's going to be in our center hash mark. Since this is a positive, 46 is to the left, 48 is to the right. That's your traditional positive number order. Does our inequality symbol have an equal to bar like I did on number 1? No. So we're going to leave this an open circle since it did not have an equal to bar. And since k is greater than, this is greater than symbol. This is not a less than symbol. It does not look like an L. This is a greater than symbol. Since it's greater than, we have to go to the right. Greater numbers will always be to the right. Now I know some of you guys might have learned a trick that the inequality symbol kind of matches the arrow for how you're going to shade. And I agree, it will, as long as the variable is written first on the left. But you don't really need to know that trick as long as you know less than goes left, greater than goes to the right. That's going to be the way this makes sense. Okay, problem number 3. Let's do one more together before you do 4 and 5 on your own. What's happening to the variable? Well, the variable is over here, and it is being added by 6. What's the inverse of adding by 6? Well, obviously that would be subtracting by 6. Let's do that on both sides. If you would like to do this without a calculator, then you would make subtraction adding the opposite, negative plus a negative. You would add in your head and get negative 34. 6 minus 6 is 0. We're left with t. But before you graph this, notice where the variable is. It's over on the right. We don't want it on the right because if we leave it there, we're going to see less than, and we're going to think we're going to shade left, and that is not going to be correct. We're actually going to shade to the right. How so? Let me prove it to you. Flip this answer around so that the variable's written first over on the left, which makes this go from less than or equal to that it used to be now to greater than or equal to, and then write the negative 34. You're like, Underkoffler, why didn't you do that on number 1 and number 2? Because on number 1 and number 2, the variable was already written over on the left. It was already beginning on the answer. Whereas here, it was not. So that's why I had to flip the whole thing around so I know what this answer actually means. T is greater than or equal to negative 34. Okay, negative 34 is going to go in the middle. Since it's negative, negative 33 is on the right, negative 35 is on the left. That's the order that negatives go. And since our inequality symbol has the equal to bar, we are going to fill in our dot, showing that it can equal the starting number. And then I just have to interpret the inequality symbol. It is greater than or equal to, because this does not look like an L, so this is greater than or equal to, and the greater numbers will be to the right. Let me make this like that. Okay. And there you go. If I go too fast on any of these problems, you're always allowed to hit pause on the video and catch up. All right, I would like for you, speaking of hitting pause, I would like for you to try number 4 and 5 on your own. Now, don't go past 4 and 5. 6 and 7 are a different ball game, and that's going to refer back to the first page of the guided notes. So just do 4 and 5 for now. Hit pause, do these problems on your own, and graph their solutions, then hit play when you're ready to see how you did. Okay, did you already do 4 and 5? Let's see how you did. What's happening to the variable? It's being added by negative 17. The inverse of adding is subtracting but we had a negative, and you're not supposed to inverse the number. You're supposed to just inverse the operation. Did you have minus a negative on both sides? Now, yours might not look like that anymore. You might have made it already become adding the opposite, proving that you would get 0, because negative 17 plus positive 17 is 0. If you're sitting at home and you're like, Mr. Underkoffler, do I really have to make it minus a negative? Can't I just make it adding a positive right away to give me the 0? My answer is absolutely yes. You guys are no longer rookies at this. If you realize that to get the 0, you're going to have to add by a positive, then you can start with that. You don't have to start with minus a negative. You can start with adding a positive. And one more thing I want to say. Do we always have to make subtraction become adding the opposite? No, you can see there are many places where I did not make subtraction become adding the opposite. But if it is subtracting by a negative, yes, make it look simpler. Adding a positive is so much easier to understand than subtracting a negative. Please make subtracting a negative become adding a positive. Okay, let's work down. This should give you 11. Now, your number line. Did you have the numbers in the correct order? That's the first thing I want everybody to check. 10 should be on the left, 12 should be on the right. That is the positive order of numbers on a number line. Since this does not have the equal to bar, you should have left this an open circle. And since R is less than, that's right, this is the less than symbol, you should have gone to the left of 11, because numbers like 10 and 9 and 8, they are less than 11, so that's the way that we should be shading. Problem number 5. The inverse of subtracting negative 35 is adding negative 35. If you want to make this add in the opposite before you work down to prove that you would get 0, that's fine with me. This is going to give you negative 27. By the way, if you made this adding the opposite first and then subtracted by 35 on both sides, that's the same thing. Don't have to erase what you had. Adding by a negative is the same as subtracting by a positive. So that would be acceptable. You would still get negative 27. Check out where the variable is. It's on the right. Well, that's not good. If you leave it there and you look at your greater than or equal to symbol, you're going to accidentally think that you're going to shade to the right. But no, 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 no. Go an extra step and get the variable written first over on the left. And then you will understand what this answer means. When negative 27 is greater than or equal to x, it means x is less than or equal to negative 27. So you're going to shade to the left, and you're going to keep this in a closed dot, not an open circle, because it has the equal to bar. And forgive me for not showing you this earlier. Do you have the negatives in the correct order? If these were positives, then 28 would be on the right and 26 would be on the left. But with negatives, it goes the other way. That's just the order that negatives go on a number line. Make sure you got every detail of 4 and 5 correct, because every detail matters. Okay, let's go back to the first page. And let's talk about a rule that you've probably never heard about before, because it never applied to equations, but it does apply to negatives. This is a brand new rule. You might want to put some stars around this, because this is something you've never heard about before, and you're going to need to learn it and memorize it from this point forward. Whenever you are multiplying or dividing both sides of an inequality by a negative number, the inequality symbol will switch direction. You're like, what? Take a look at my examples. Problem number 3. The variable was being multiplied. The inverse is to divide, but since it's a negative, we're going to divide by a negative on both sides. As this rule says, when you multiply or divide both sides by a negative, the inequality symbol must switch direction. So it used to be greater than or equal to, but since we divided by a negative, it's going to become less than or equal to. It switches direction. Problem number 4. What was happening to the variable? It was being divided by negative 6. Inverse is to multiply, but since it was negative, we're going to keep it negative because we don't do inverse numbers. We only do inverse operations. Since we are multiplying by a negative, the rule says when you multiply or divide both sides by a negative, the inequality symbol will switch direction. So boom, it used to be less than, now it switches direction to greater than. Why? Because we multiplied by a negative. Or same thing, when you divide by a negative, like on number 3, it's going to make the inequality symbol switch direction. Now, don't be fooled. Just because you have a negative on the answer does not make the symbol switch. Look at number 5. This inequality symbol does not switch. It's still the same. Now why? Look what I did on both sides. I divided by a positive. Does dividing by a positive switch the inequality symbol? No. Only when you multiply or divide by a negative on both sides. And 25 here is not negative. So even though the answer has a negative, you did not divide by a negative. And that's why the inequality symbol did not switch. Take a look at number 6. Well, here I have a negative, but am I multiplying or dividing by a negative? No, I'm adding by a negative. Did the rule here say that it switches direction when you add by a negative? No, only when you multiply or divide by a negative. So that's why the inequality symbol did not switch directions here. It only switches direction when you multiply or divide both sides by a negative number. So you can write this down real quick. This is why the inequality symbols did switch on 3 and 4, because I did multiply or divide by a negative on both sides. But it did not switch on 5 and 6, because here I divided by a positive, here I added by a negative. It only switches direction when you multiply or divide both sides by a negative number. Okay, if you have that written down, let's practice this. Turn back to the second page. Let's do 6. Let's do 7. What's happening to our variable? You can see the variable's right next to negative 9. That means multiplication. So the inverse is to divide. But we are dividing by the negative. We don't ever inverse the number. We only inverse the operation. So write this down properly. We are dividing by a negative. Let's skip to number 7. I know I haven't finished number 6, but let's skip to number 7. What's happening to the variable in number 7? Here it's being multiplied by a positive 7. Inverse is to divide by 7 on both sides. Write that down. And now let's finish these two problems. You can use a calculator. 162 divided by negative 9 will give you negative 18. On number 7, negative 161 divided by 7 gives you negative 23. One of these inequality symbols will switch direction. One of them will not. Can you figure out which one it is? Hit pause, flip back to the first page if you need to reread this rule and look back at our examples and counter examples. I want you to figure out which one will the inequality symbol switch and which one will not. Have you figured it out? It's going to switch direction on number 6 because anytime you multiply or divide by a negative on both sides, inequality symbol will switch direction. But on number 7, we're dividing by a positive, so the inequality symbol does not switch direction, and that's why it does not switch. Okay, let's quickly graph these guys. Negative 18, the negative numbers go in this order. Number 7 also had negatives, so these are reverse order from positives. This is why negative 22 is on the right and negative 24 is on the left. Both of these are going to get open circles because on both of these answers, the inequality symbol did not have an equal to bar. If W is greater than negative 18, then we go to the right because greater numbers will always be to the right. But when it is less than, this is less than on number 7 because it looks like an L, then we are going to shade to the left. As you go to the left, the numbers will always get less. Let's do one more together. Problem number 8. What's happening to the variable here? Here it's being divided by negative 27. Inverse is to multiply by negative 27. We're going to do that on both sides. You can use the calculator if you want. A negative times a negative will be a positive 243. Should the inequality symbol switch direction? Why, yes, because when you multiply by a negative, the inequality symbol should switch direction. This is going to happen anytime you multiply by a negative on both sides or when you divide by a negative on both sides. But before we graph, is this variable where we want it to be? No, we want the variable to be on the left. So, anytime the variable ends up on the right, you're going to have to do an extra step underneath and flip the whole thing around, making this m is less than or equal to 243. I know you're like, really? I had to do a double flip? I had to flip when I multiplied by a negative, and then I had to flip again? Yeah, this is one of these rare problems where there's ending up being a double flip, but they're for two totally different reasons. The first flip was immediately after I multiplied by a negative on both sides. The second flip had nothing to do with negatives. The second flip was because the variable was on the right, and I want the variable to be on the left. So those are two different reasons why the inequality symbol had to flip. Okay, 243 is in the middle. 242 is on the left, 244 is on the right, because that's the order of positives. Since this had an equal to bar, we have to put a closed filled in dot. And since our inequality symbol says that the m is less than or equal to 243, we are going to go to the left. Less than is to the left, because that's where the numbers get less. Okay, there are other practice problems to go, but I think we are going to save that for part 2 of this video. So thank you for watching part 1. We'll see you next.